EskewDumezRipple is a 50-person firm that practices nationally, but a lot of our work is in the Deep South, particularly in Louisiana. We have, for now the last 8 years, sponsored a research fellowship program within our firm that helps us deal with the fact that there are so many things we all wish we knew some more about, but can never quite carve out the time and the discipline, frankly, to do it. We've used the fellowship to address issues ranging from building performance, resilience, community engagement, sound, the biological effects of sound and light on the human brain, and so on. But most recently, starting last year, we looked at the question of what would it really take to implement the zero code in all of our projects, and how could we ground that in real-world results with real-world cost data. And so to do that, we made our research theme last year, we called it Deep Impact Paths to Carbon Zero, because there isn't just one path, there are many paths. And the 12-month research fellow that year, Kelsey Wotilla, will present as part of this session and show what her key results are. And she took on the hardest question that was left out there, which is, we've always just said mechanical systems are this, they sound hard, so we'll just say that they don't count in our analyses. But she formed a partnership with some area mechanical firms and can talk about the results that she found for understanding the embodied carbon in projects, both renovation and new construction. And then this year that we've transitioned to the other great mystery in embodied carbon, which is structural systems. If Michael Pollan in his book, The Omnivore's Dilemma, said, eat food, not too much, mostly plants. And so for architects, our realization is that the current received wisdom is build buildings, not too big, mostly wood. And so as part of that effort, we've said, well, what does it take for wood to really be good? And so Brennan Donnelly here has done research on what makes wood something that's actually environmentally positive, the use of wood in buildings, what would that take? And then secondly, we've asked Jake Elbrecht is taking on a year-long project to develop a set of tools to kind of lower the threshold for architects who are interested in using mass timber or long span dimensional lumber and so on. What are the tools they need to answer the questions about, can this work in my project?
So here at EskewDumezRipple, the Paths to Carbon Zero Research Fellowship had 2 tracks. One, measuring embodied carbon of a portfolio sample of our projects, and 2, seeing how much it would cost to meet the zero code standard in each of our projects. So we took a sample size representative of our portfolio of 8 projects across project types and locations and budgets to see what it would take to meet zero code and where we land on the embodied carbon scale. Spoiler alert, meeting zero code standards was a pretty simple thing for us to achieve in design. And the second piece of zero code is offsetting the rest of your energy use. So that could be a solar installation on site power, or you could purchase renewable energy certificates. What we found is renewable energy certificates are what the market is ready for. From an embodied carbon standpoint, we kind of reinforced what we knew, that by picking your structural system, you can find significant reductions in embodied carbon. And then we started to explore a little further at life cycle analyses and recognized that MEP systems need to and can be measured for their impacts, and that they can be pretty significant. And what we found within that study of MEP systems as well was that retrofits provide both savings in embodied carbon and operational carbon. So in designing to zero code, the first step is designing to the ASHRAE standard 2016 90.1. And compared to a baseline average US building, what we found by designing to that standard across our projects as a firm-wide policy is we'll get about a 45% reduction in energy use intensity, which is great. But we wanted to know how much that cost. Clients tend to care about the dollar as well. So that translates to about a 60% savings in your annual energy bill just in designing a better, more efficient building. The next piece of zero code, though, is to offset that actual energy use through clean energy. And what we found is that comes at a very small price premium, about 5%. So you're still saving from a baseline building about 55% annually in your energy bill. Now, that premium is affordable in the context of purchasing renewable energy certificates, and it's about a 5% premium to your annual energy bill, which translates to about 5 cents per square foot on most of our projects. The other option is to buy the clean energy, buy the infrastructure, which is on-site solar and costs a little bit more. You're buying instead of renting. So $5 a square foot is what we found to be true. The next piece we started to examine was sorting our projects by structural system and where we land in embodied carbon. No surprise, concrete was the heaviest and wood is the lightest. So if we're able to trade out from a concrete system to a wood system, we will find a significant embodied carbon savings just in choosing your structural system wisely. The other thing we found is that in concrete buildings specifically, you can still find a 10% optimization within the system at little to no cost, specifically by looking at fly ash mixtures. Our heavy hitter for embodied carbon savings is in the form of retrofits. That's where we found about an 80% savings compared to building a building new. So we looked at a specific case study and found exactly that an interior renovation came in at about 80% of what it would have taken to build the building new. But that retrofit came with MEP upgrades as well, so we wanted to measure those. And we found that MEP systems need to be measured, and especially in retrofits, can be about a 40% contribution to embodied carbon. But the thing with retrofits, especially MEP retrofits, is it addresses both embodied and operational carbon. And for this project, we found it's a 1-year carbon payback, including the MEP system in what you end up saving in operational carbon. So while we need to measure MEP systems that they can be 40% of a project's footprint, MEP retrofits provide scalable, impactful, embodied, and operational design decisions that we can execute now to meet the zero code. So in Paths to Carbon Zero, we found pretty simply it's affordable to meet the zero code standard and be operationally carbon zero. The other piece we found is embodied carbon is a bit trickier, but by focusing on structural systems, we can get there. And don't forget to meet with your MEP team and start measuring your MEP systems. But the other takeaway is focusing on our structural choices. So what can we do with a good structure? What can we do with wood?
When we look at projections in new construction between now and 2050, we see the critical role that embodied carbon plays.
Structural systems in our buildings have been predominantly concrete and steel over the past century. And despite increasing efficiencies in their production processes, they remain significantly more energy intensive to produce in comparison to timber. By reducing our use of energy intensive construction materials, combined with the photosynthetic absorption of carbon dioxide in forest growth cycles and the sequestration of carbon bound up in harvested wood products, we start to see a compounding carbon benefit. So in researching what exactly this could mean at scale, we needed to identify several key factors, the first being the potential market for mass timber in the US in terms of residential and commercial construction. The volume of timber needed to supply that potential market, while closely reviewing forestry data to determine the extent in which our forests could handle this sort of intervention. And while doing so, we also wanted to maintain the notion that the domestic softwood growing stock would continue to increase, given the rate in which it has been in the past 40 years. And what we found over the course of the next 30 years, this scenario could sequester as much as 1.5 gigatons of carbon dioxide through the timber itself, avoiding nearly 1.8 gigatons of carbon dioxide through using less concrete and steel, with an overall carbon benefit of 3.3 gigatons. A carbon impact like this could reduce global emissions specific to embodied carbon from the building sector by as much as 3%. And while this study, in which mass timber is the deciding material for all commercial and a significant portion of residential projects, may seem improbable, architects need to start thinking at scale like this to make shifts in practice if we're at all serious about mitigating climate change.
We know that wood has the potential to play a major role in reducing the embodied carbon of our future structures. Now, this will require a significant shift from the conventional steel and concrete used today. For most architects, this will put us back at the bottom of the experience curve.
The Midrise mass timber design tool aims to shorten that curve by providing architects with a design space for early design development where they can quickly iterate through ideas and understand the overall implications of their designs. The tool works by connecting a series of structural tables together that enable the model to generate a three-dimensional representation of that design. From there, adjusting the input parameters allows the user to see what happens when something is changed, such as the column span. The implications can then be understood by comparing the total material cost and total carbon sequestration between iterations. An example is a model that utilizes a 20-foot by 20-foot column grid. Changing the platform input parameter between different plies of CLT would allow the user to quickly see the different beam depths and the number of beams required for each iteration. They could quickly determine if it was more efficient to use a thinner panel with more beams or a thicker panel with less beams.
Ultimately, this tool is intended to help architects get more comfortable with mass timber at the beginning of the project rather than later down the road. Now, we are fighting a global climate crisis, and the materials we use today will have a significant impact on what happens between now and in 30 years.
So what we like to say is that ADR, our goal is to apply leading edge tools for trailing edge clients, for clients who might not be necessarily into the whizziest stuff. They might not be having the sustainability might not be their number one priority. But we'd like to find ways that by integrating that into everyday practice, to making it practical, to make it accessible, that we can provide a model for firms across the country to transform architectural practice. Thanks.